So today in lesson 1.1, we're going to look at solving simple equations. All right, so let's first of all look at the essential question. It says, how can you use simple equations to solve real life problems? So here's my first question. What is a simple equation? There's a couple different answers that I'll take here, but does anybody remember or know what a simple equation is? You want to try?
Only has one equal sign.
Okay, has one equal sign, one variable. All right, but another thing I'm looking for, if I were to give you the problem 2x equals 12, how many numbers are keeping this variable from being by itself? Look at, right, there's only one number that's keeping the variable from being alone. So this simple equation is also known as a one-step equation. All right. So since there's only one number that's keeping our variable from being alone, this is a simple equation or a one-step equation. All right. So today that's what we're going to look at. We're going to look at simple one-step equations. Now, the steps to solving an equation. Before we can do that, let's talk about the difference between an equation and an expression. Because if you look at the definition of equation, it says a statement with two expressions set equal. So what is the difference if I were to give you 3n equals 12 and just 3n? Which of those is an expression and which of those is an equation? Alyssa, which of those is an equation? Very good. The equation has the equal sign. So how are we going to remember that? If I look at the first four letters in the word equation and I look at the first four letters in the word equal, they are exactly the same. So an equation has an equal sign. Now, if I want to solve an equation, the first thing I'm going to do is I'm going to find the number that's keeping the variable from being alone. If that's my whole goal, to isolate that variable, then I got to find the number that is keeping the variable from being alone. Then I'm going to move that number with an inverse operation. Now let's talk about operations real quick. Let's go back to elementary school. What are the four basic operations in math? Olivia.
Addition, subtraction, multiplication, and division.
Very good. Addition, subtraction, multiplication, and division. So when we talk about inverse operations, we're talking about operations that undo each other. So, for example, if I'm adding a number, what is the inverse or the opposite of adding a number? Class? Subtracting a number. Very good. If I'm dividing a number, what would be the opposite of dividing or the inverse of dividing a number? Multiplying. So addition and subtraction undo each other. Multiplication and division undo each other. So that's what we're talking about when we say inverse operations. Now let's look at this first problem. If I'm adding 28, what would be the inverse of adding 28? Subtracting 28. So I'm going to put minus 28 and I'm going to box it in. All right, Emma, if I'm subtracting 15, what's the opposite of subtracting or the inverse of subtracting 15? Good, I'm going to add 15. All right, what about multiplying? Claire, if I'm multiplying 7, what is the inverse of multiplying 7? Dividing 7. Awesome. And if I'm dividing negative 17, Noah, what would be the inverse of dividing negative 17?
Multiplying by negative 17.
Multiplying by negative 17. Now let's talk about this for just a second. You're going to notice that I don't use x's for multiplication anymore. I don't like to be confused as to whether I'm looking at a variable or a multiplication symbol. So we're going to use a lot of dots, we're going to use a lot of parentheses, but we're not going to use x's anymore. Okay? I also put the negative 17 in parentheses because we don't like two math symbols side by side. All right, but notice when the inverse operation, when it started as division, did I change my sign when I multiplied? Yes? No? Maybe? No. The problem said divide negative 17. Well, the inverse of that is to multiply by negative 17. So keep in mind, signs will only change if my inverse operations are addition and subtraction. All right, any questions so far? All right, now let's look at example 2. It says solve the equation. So let's talk through the first few of these kind of slow, just so we can refresh our memory. In letter A, Gage, what is the variable that we are trying to isolate? The n. And in order to isolate n, I need to move what number? 3. What inverse operation am I going to use to move it? Subtraction. Now, if we remember the addition and the subtraction properties of equality, it says what we do to one side, we must do to the other. So, we are going to show on both sides of the equation that we are subtracting 3. Now, a positive 3 minus a 3 is 0. And since we have an n we can bring down, there's no reason to bring down a 0 as well. We're just going to cross out the 3 minus 3. We're going to bring down the n. Okay, now look at the numbers on the right. And we're doing a whole lot of things in this one lesson, so I'm asking a lot of questions. The signs. Every number has a sign, and the sign is directly in front of it. Do these signs, a negative 7 minus 3, are the signs the same or are they different?
Same.
And what do we do when our signs are the same? Add and add and keep. We add the numbers and we keep the sign. So 7 plus 3 is 10. And then, of course, we're going to keep the negative sign. So n is equal to negative 10. All right, great job. Olivia, letter B. What's the variable that I'm trying to isolate in letter B? G. So what am I going to have to move? The 1/3. And how am I going to move it to the other side? The inverse operation is going to be to add 1/3. Now, we are not going to panic, even though we have fractions. First of all, negative 1/3 plus 1/3 is 0. So we bring down the g and the equals. Let's look at our fractions. First of all, do our fractions have a common denominator?
Yes.
Awesome. So we're just going to bring down our denominator. Now we're looking at a negative 2/3. Here's what I need you to understand. When there's a negative in front of a fraction, we can assign it to either the numerator or the denominator. In this case, what would make the most sense? Right. We don't want to add it to the denominator because then we have a negative denominator, which is weird. So that's a negative 2 plus 1. So this time, are my signs the same or are they different? They're different. And when my signs are different, what am I supposed to do? Subtract and take. Subtract and take. So we subtract 2 and 1 and we get 1. We take the sign of the bigger number. So which number is bigger? The 2 or the 1? 2. If we're not considering the signs, 2 is definitely bigger. So we take the sign of the 2 and it was negative. So G is equal to negative 1/3. All right? Any questions so far? Awesome. I want you to work with your partner and I want you to work letter C and letter D. Take a minute and work with your partner. All right, let's look at letter C. Isaiah, what was the variable that we were trying to isolate in letter C?
Y.
Okay, and so what do we have to move in order to get y by itself?
2.8.
And how did you move it to the other side?
Subtract 2.8.
Very good. The inverse operation would be to subtract negative 2.8. All right, so y equals, what is 0.9 or 9/10 minus 2 8/10? Isaiah? Don't forget have your calculator with you, okay? Set it on the board. It'll be one of those staple things every single day, pretty much. So who can tell us what 0.9 minus 2.8 is? Emma, did you get an answer?
I got 6.2.
All right. Be really careful. That is a 0.9. Did you use it as a 0.9? Yes. Okay. That's okay. That mistake's been made often today. That's a 0.9. That's 9/10 minus 2 8/10. All right. Olivia, what did y'all get?
1.9.
Say it again.
1.9.
All right. Positive 1.9? Good. We got to take the sign of the bigger number and the negative, the 2.8 is bigger. So it's a negative. Now I want you used to putting the variable first. So we're just going to flip that answer before we box it in. All right. We want our variable first. All right. What happens on letter D? Gage, what happened on letter D? What are we trying to get by itself? All right. So you had to move. And how did you move it? Good. It's minus 3, so the inverse would be to add 3. So x equals what, Gage? Negative 2. Awesome. How many of you got x equals negative 2 on letter D? All right, great job. Any questions? Okay. When we continue, I want you to look at E, F, G, and H. We're still trying to solve the equation. All right, but let's look at what kind of equations we've got this time. Noah, I want you to read letter E to me.
Negative n over 5 equals negative 3.
All right, here's my only problem with what you just said. And I'm okay that you said it because it's a mistake that gets made a lot. So I'm actually glad you said it. Over is not an operation. So when we see a fraction, what kind of a problem are we actually looking at?
A division problem.
A division problem. Anytime you're looking at a fraction, you're looking at a division problem. So I want you to read it again and give me an operation this time.
Negative n divided by 5 equals negative 3.
Very good. So that's a division problem, which means our inverse operation is going to be what? Multiplication. Now, before we do anything else, let's look at, we have a negative sign in front of a fraction. So we got to assign that negative to either the numerator or the denominator. Haley, which one makes the most sense?
To the numerator.
All right, if we give it to the numerator, though, we got a negative variable. And can we have a negative variable in our answer? No. So let's not do that to ourselves. Let's go ahead and assign it to the 5. So let's rewrite this problem. All right, let's rewrite this one. And let's go ahead and assign it to the denominator. Now, Noah, back to you for a second. You told us we were going to multiply. What are we going to multiply both sides by?
5.
Careful. Remember, when our inverse is multiplication or division, do we ever change the sign?
No.
No. All right. If I simply multiply by 5, is that going to cancel? No, that's going to leave me with a negative 1, which I don't like. So when I am multiplying both sides, my sign will never change. So I actually have to multiply both sides by a negative 5. Because when this negative 5 right here is the numerator and this negative 5 is the denominator, now they cancel each other out. What do they equal? If you saw it as negative 5 over negative 5, anything over itself equals what? 1, not 0, although we think that sometimes. It is 1. So just like the 0, though, we don't need to bring it down. So we are just going to bring the n down. And now look, we've got a negative times a negative. What do we get when we multiply a negative times a negative? Positive. So negative 3 times negative 5 is positive 15. Awesome. That's our answer. All right, letter F. Esther, read letter F to us.
1.3 z equals 5.
All right, now go back, read it again, and give me an operation.
1.3 times.
Very good. Remember, a number and a variable with nothing between them is multiplication. Also, a number and a parenthesis with nothing between them is multiplication. Multiplication is that one operation that does not require a symbol all the time. All right, you'll always have an addition sign, always a subtraction, always a division. But multiplication is a little bit different. So 1.3 or 1 3/10 times z equals 5 2/10. So Esther, what do I need to move to get z by itself?
1.3.
And how am I going to move it?
Going to divide it.
Divide it. Now, another thing you'll notice, I use fraction bars to show division. Don't use division symbols. We're going to use fraction bars. So we're going to divide both sides. Again, what we do to one side, we must do to the other. So we're dividing 1.3 on both sides so that z equals, anybody work that out already? 4. Very good. So z equals 4. Okay? Now, I want you to take a minute, work G and H with your partner. G and H, work with your partner. All right, Amy, tell me what you did on letter G.
Divided both sides by 5.
Good. I'm trying to isolate G, so I've got to divide both sides by 5. So what does G equal?
4.
Good. How many of you got G equals 4 on letter G? Great. All right, Isaiah, letter H, read it to us first. Let's read it first.
Negative 7 equals t divided by 7.
Very good. And so in order to isolate t, what did you have to do?
Divide 7 by both sides.
Divide it?
I mean multiply 7.
Good. It's a division problem already, so the inverse is multiplication. So these 7s cancel and equal 1, so we just bring down the t. And what is 7 times negative 7?
Negative 49.
Good. A positive times a negative is a negative. So again, let's make sure we put our variable first, and t is equal to negative 49. Any questions on this page? All right. Now, if we look at letter I and letter J, the first thing we want to do is figure out, are we looking at a addition simple equation, a subtraction, a multiplication, or a division? So if you take a minute and you read these, that says 10 equals negative 2/3 times m, which means that our job is to move the negative 2/3. And how are we supposed to move the negative 2/3? What is the inverse of multiplication? Let me ask the question again. What is the inverse of multiplication? Division. So if this is a multiplication problem, which it is, we are supposed to be dividing both sides by the negative 2/3, correct? However, if you think back to what you learned in elementary, can you divide fractions? Nobody? Can you divide fractions? Or do you have to flip the second fraction and change it to a multiplication problem? Yes. You can't divide fractions. So we are going to save ourselves some time. If we're looking at a multiplication problem and the number we have to move is a fraction, we are simply going to multiply both sides by the reciprocal. So without dividing both sides and then flipping things, let's go ahead. If the number we're trying to move is a fraction and it's a multiplication problem, we're just going to go ahead and multiply both sides by the reciprocal. Now let's talk about a reciprocal. If I give you 1/2, what's the reciprocal of 1/2? 2 or 2 over 1. If I give you, Claire, if I give you negative 4, what's the reciprocal of negative 4? Remember, when I have a whole number, how do I make it into a fraction? I put it over 1. So what would be the reciprocal of negative 4 over 1? 1 over negative 4. Good. So remember, the reciprocal, you take the fraction and you just flip it. Now, if we look at letter I, we have a negative 2/3. So let's assign the negative to either the numerator or the denominator. Isaiah? You want to give it to the numerator or you want to give it to the denominator? Numerator. So you're saying negative 2/3 times m. Okay, so if we're going to multiply both sides by the reciprocal, Isaiah, what's the reciprocal?
3 divided by negative 2.
3 divided by negative 2. So we're going to multiply both sides by 3 divided by negative 2. Now over here, still should cancel to equal 1. A number times its reciprocal still equals 1. So it cancels out. And be very careful. That's a 3 over negative 2, okay, times a 10. But remember, 10, if I want to write it as a fraction, is going to be 10 over 1. All right? So if you're working it out on paper, just keep that in mind. Or if you're sticking it in your calculator. Either way, what is your final answer going to be? Noah.
M equals 10.
All right. Be really careful, Noah, because if I'm multiplying my numerators, I'm getting 3 times 10, which is 30. And if I'm multiplying my denominators, a negative 2 times 1 is negative 2. So what is 30 divided by negative 2?
Negative 15.
Negative 15. And again, we're going to flip that, so m is equal to negative 15. All right, so be really careful. This is just an extra step right now for you to see what we did. You can also simplify before you multiply. 2 goes into itself once, and 2 goes into 10 5 times. So that would mean I'm doing 3 times 5, and I would have got that 15 a lot quicker. So there's a couple different ways. You can use your calculator. Punch it into your calculator, and you'll get negative 15 even faster. But these are the different ways that you can get to your answer. All right, take a minute and work J with your partner. All right, Emma, what are we trying to move so that D will be by itself? What's keeping D from being by itself? What's the fraction? 1/6. Okay, 1/6. So if I'm going to move 1/6, how am I supposed to move the fraction? Okay. So I'm going to write the reciprocal, which is 6/1, and I'm going to do what with it on both sides? Good, I'm going to multiply it. So over here, it simplifies to 1, which I don't need. And over here, what happens? What's 5/6 times 6/1? Or 6? 30 over 6, which is just 5. Okay, again, you can multiply and do the math and then divide, or the 6 goes into itself once and the 6 goes into itself once, so we end up with 5, right? Or stick it in your calculator. But D equals 5. Okay, any questions at all? Now, the essential question at the beginning of the lesson said, how can I solve simple equations in real life problems? So here's where we're going to put that into practice. Whenever I give you a word problem like this and it says write and solve an equation, we are looking to write a problem that looks like the ones we've just been learning how to solve. So instead of just giving me an answer, doing this work in your head and just giving me an answer, I am looking for you to be able to write the equation and then solve it. So let's break this problem down. It says the selling price of a certain video. So the first piece of information they're giving us is there's a selling price. So I'm going to go ahead and use the letter S for selling price. It says the selling price of a certain video is. Does anyone remember what math symbol we can replace the word is with? You're thinking in the right direction. But if the selling price of a certain video is, then the selling price equals. All right, very good. So the word is, when we're talking in the math context, can be replaced with an equal sign. So the selling price of a certain video is 7 more than. Now, more than indicates what operation? Addition. So I'm going to go ahead and write plus 7 because I know that it's $7 more than something. So I'm going to add 7. Now, it's $7 more than the price the store paid. So I've got the selling price. It is $7 more than the price the store paid. So I'm going to use a P to represent the price the store paid. Now we've got 2 variables and we only can have 1. So let's keep reading. If the selling price is $24, find the price the store paid. So $24 can replace which of those variables in my problem? S, because the selling price is 24. Now does this look like a problem that we've been learning how to solve today? Yes. So we want to solve and find the price the store paid. So Haley, what do I need to do to get P by itself? Subtract 7. Now one thing I want to remind you, P equals 17. I want to remind you that word problems need labels. So this is $17, so a dollar sign is perfectly acceptable. But make sure when you're working a word problem, you're labeling your answer. So the store paid $17, then they charged an extra $7 to make the selling price $24. It's how they make money. Okay, so here is how solving a simple equation works in the real world. Okay, any questions? Good, look at letter B. With your partner, I want you and your partner to see what you can figure out about letter B. All right, you're loading a large pile of newspapers onto a truck. It says you divide. So right there, we know that our problem is a division problem. We're dividing it into 4 equal size bundles. So if I'm dividing by 4, is my numerator 4 or is my denominator 4? My denominator, okay? It says you find that one bundle weighs 37 pounds. So here's the question. Is 37 the number that I'm dividing by 4? Or is 37 the result of dividing by 4? It's the result. Because I'm going to take one big stack and I'm going to divide it into 4 smaller. And I know that one of them is going to be 37. So the weight X of the original pile means my numerator is my unknown. My numerator is that full stack, the full weight of the newspapers. I'm going to divide that by 4, and each pile is going to be 37 pounds. Does this look like an equation that we've been solving today? Yes. Okay. So how are we going to get x by itself? Olivia?
Multiply times 4.
Good. If it's a division problem, I'm going to multiply both sides by 4. So my 4's equal 1, and x equals 148 what? Pounds. Very good. Don't forget that label. Okay? So that is lesson 1.1, and that is how we can use simple equations in real life situations.